Okay, so we are going to split section 5 from the prerequisite chapter into 2 parts. Make it a little shorter, a little more manageable, and hopefully then we'll be able to master it a little bit more. So first part, we're going to talk about identifying the greatest common factor and then factoring that out. Then we're going to do something called factor by grouping. And finally, we're going to look at trinomials, some where a is equal to 1, some where a is not equal to 1. So first part, greatest common factor. If we are going to factor using the greatest common factor, we're looking for the highest degree and factor that divides each term. And remember here we're dividing, and this is going to be the opposite of distribution. So if we look at this first one thing we probably want to think about doing is thinking about a pair of parentheses here, and we're trying to pull something out. So we need to think about what number divides both 18 and 27. Well, most of us probably can recognize that we know we can factor out a 9. Then we also we need to look at our x terms. So we have an x cubed and an x squared. Now what x cubed means is it's really x times x times x, and x squared is x times x. So in this case we can think of factoring out an x squared or xx from each one. So I'm going to write x squared as the other piece I factor out. So my greatest common factor from this is 9x squared, which means really I'm dividing each term by 9x squared in order to do the opposite of distribution. So 18 divided by 9 is going to give us 2, and if we had x cubed and we factored out 2 x's, we still have 1x left. Plus 27 divided by 9 gives us 3, and if we factored out 2 x's, none of our x's are left in here. Our x squared is gone, so it's just 3. And this would be factored based on the greatest common factor. Okay, second one is going to use that again then, but before we do that, we're going to group terms with a common factor, and then we're going to factor out the greatest common factor. So what I mean by group terms with a common factor, typically since things are going to be written or should be written in standard form, meaning their degree is decreasing, we're going to group by putting our first 2 terms together plus our last 2 terms together. And now we factor out a greatest common factor. So again, just like the last example, x cubed and x squared, that tells us we can factor out an x squared, which means 2 of these are gone and we just have 1x left on the inside. Plus, we can factor out this x squared, which means we just have a 4 left. Plus, moving along then to our second group, there are not x's in both, so we can't factor out an x, but we can divide both these terms by 3. So we can pull out a 3, and we'll have x plus 4 left on the inside. Now, one important thing is that these 2 pieces inside have the same value. If they don't, we either factored out the wrong greatest common factor or it's not factorable. It's most likely going to be that we factored out the wrong greatest common factor. Now, the way to look at this is that we have kind of 2 different terms here in our overall. We have an x squared times x plus 4, and we have a 3 times x plus 4. And you'll notice that both of these terms, this whole thing is one term, this whole thing is another term, both of them have an x plus 4. So when we factor by grouper, we're finding the new greatest common factor is actually x plus 4. And then what we have for our other 2 terms is what we have left after we factor out that x plus 4. So x squared plus 3. We just brought these 2 down. And this now would be factored. Now, one thing that in the past I've seen students get tripped up on a lot, suppose that this term right here had been something like x squared minus 16. This is something called a difference of squares, and we're going to cover this more in the second video, but we need to understand that anytime it's minus and a perfect square here, we could factor that again. And it'd be x plus 4, x minus 4. Again, we're going to cover that more in the second video, but just recognize that sometimes after you do factor by grouping, you're not necessarily done. Sometimes you need to do an extra step. Okay, moving on then to factoring trinomials. This is something you would have done in Algebra 1. Form is ax squared plus bx plus c. Now sometimes our degrees here could be different, but as long as this is twice whatever the degree of the second term is, we're okay. And again, it's important here that a equals 1. It's going to be the opposite of FOIL, and we're basically looking for the factors of C that add up to B. And you're going to rewrite it as 2 binomials based on those factors. So in this case, C is 40, b is 13, and we're looking for factors of 40 that add up to 13. So some factors of 40 I know would be like 4 and 10, but that adds up to 14, so that's not going to work. We could say 2 and 20, but we get 22, so that's not going to work. Some other factors, how about 5 and 8? So that works because 5 plus 8 equals 13, which is what we want it to be. Now, when a is 1, this is the important piece. When a is 1, it's pretty easy. We're done. We're just going to rewrite this as two binomials, x plus 5 times x plus 8. That's it. And because they're both positive, they're both going to stay plus. Okay, if we had different signs of 40, that will create some different circumstances, and you'll see an example of that in the first or the next question that you have. So it gets a little more complicated when a is not equal to 1. Again, same idea, same form. It's still going to be the reverse of FOIL. Though instead of wanting to use just c this time, we're going to find the factors of a times c. So this is an important piece. We're still trying to find them, find the ones that add up to b. And then we need to rewrite it as a trinomial of 4 terms. So we're splitting the bx term, to those factors into 2 terms, sum of those factors, essentially. And then we're going to do factor by grouping. So it's important that we understand how we do factor by grouping. So in this case, we have a is 8, and c is -3, which means if we do a times c, we're going to get a -24. And we want factors of -24 that add up to -10, because right here we have that b is -10. So we can do, now because this is negative, this is another place we need to be careful. Because this is negative, one has to be positive, one has to be negative. So we could say something like -3 and +8, which would give us a +5. Or you'll notice that if we change those signs, whoops, that should be -8. If we change the signs, we make the -3 positive and the 8 negative, that would give us a -5. And that's, again, if we're adding those. So you'll notice when we change the signs, it just changes the sign of the answer, but the number stays essentially the same if we're talking about absolute value. So some other options, a lot of times students in this case will say 4 and 6, because 4 times 6 is 24, or maybe -4 and -6, because that would add up to -10. But the problem is that doesn't give us -24. Really, one would have to be positive, one would have to be negative, and that's only going to give us 2. So none of these first option works. What will work is if we say 2 and -12, because that's going to give us a -24, and that adds up to a -10. So what I mean by, so we found this first step, right? Find the factors of AC that sum to B. Use these 2 factors to rewrite the trinomial as 4 terms. And like I said, we're splitting the bx term. So what that means is we're going to take that trinomial that we had, that 8x squared minus 10x minus 3, and this middle term, based on these 2 factors, is how we're going to rewrite it. Meaning we leave the first term alone, plus, take our first one here, 2x minus 12x, and I'm actually going to say plus a -12x, and then minus 3. And it'll probably always be easier if you say plus a negative here, and you'll see why in a minute. So now we've got them rewritten as 4 terms, and it's still equivalent because we just separated -10 into 2 and -12, which still adds up to -10. Now we're going to do factor by grouping. So I group my first 2 terms, and I group my second 2 terms, and this is why it's important that we bring in the negatives so that we just have a plus here. Looking at my first parentheses, they both have an x, and we can divide both 8 and 2 by 2. So I'm going to pull out or factor out a 2x. 8 divided by 2 is going to give me 4, and x squared divided by x is going to give me x. Plus, be careful here, 2x divided by 2x just leaves me with 1. Plus, and you'll notice here that both of these are negative, so we want to pull out a negative value. And we can divide them both by -3. And so -12 divided by -3 gives me a +4, still have the x, and -3 divided by -3 gives me a +1. So just like the factor by grouping piece, it's important that we have these 2 equal. And that is what we're going to factor out to create our 2 binomials. 4x plus 1 and 2x plus or minus 3. Plus a negative 3 or minus 3. Okay. Again, same trick can exist. If this doesn't start as an x squared, as a quadratic, then you could have one more step to do here. All right, but that's it for this lesson. So hopefully we kept that a little bit shorter. Greatest common factor is an important one from this lesson. You really notice that almost each step we did, we had a greatest common factor out. We used it in grouping, and we used it in the trinomials when a was not equal to 1. Okay, so tomorrow in class we'll be practicing some stuff like this, or next session in class, and then your homework for the next day will be part 2. Okay, see you next time.